Well, welcome back. We are going to talk about scale drawings and models. This is the last section of our chapter. A scale drawing or scale model is sometimes used to represent something that is too big or too small for us to actually draw or build the actual size. So the scale is the ratio of a length on a drawing or model to its actual length. Okay, you often see this in drawings of buildings and things like that that are much, much larger, or things that are very, very small on a molecular level. So some examples are 1 inch is equal to 4 feet. You might see that on a map. 1 inch represents an actual distance of 4 feet, or as a ratio of 1 to 30. 1 unit represents an actual distance of 30 units, whatever the units are. Distances on a scale drawing are proportional to distances in real life. So therefore we can use our proportions to go ahead and solve these. Here's a geography example. It says use the map to find the actual distance between Grenada, Mississippi and Little Rock, Arkansas. So I have a line drawn on the map for you, and we want to find the distance on that, the actual distance to go from those two towns. They are telling us that the distance on the map is 5.2 centimeters, and we have a key here telling us that 1 centimeter is 50 kilometers. So with that information, we should be able to figure out what the actual distance is. So if we let x represent the actual distance to Little Rock, we can say 1 centimeter is to 50 kilometers from our key. Okay, 1 centimeter on the map represents 50 kilometers in actual life. And on the map we have 5.2 centimeters is what we measured between those two towns. And that's equal to our unknown kilometers. So once we have a proportion set up, we can do the cross products and multiply. 1 times x equals 5.2 times 50. When we multiply the 50 times 5.2, we get 260. And remember, our units for x were in kilometers. So that tells us it is 260 kilometers between those two towns. Another way to solve the same problem is to use an equation. And to use an equation, we're going to use the scale that was given in the map of 50 kilometers to 1 centimeter. So we're going to write the actual distance is 50 kilometers per centimeter times the map distance. So in equation form, it would be A for the actual distance equals 50 times m. And m is going to be what we measured as 5.2 centimeters. And when we do that, we get 260 kilometers. Here's another geography example. It says use an inch ruler and the map shown to find the actual distance between Charlotte and Spartanburg and measure to the nearest quarter inch. So first of all, let me go ahead and write our equation for this one. And just like the last one, we'll say the actual distance is equal to, now in this one we have 25 miles per inch. So we're going to say 25 times whatever we measure m, the measured unit. So let's go ahead and move our ruler up here, and here's where we start measuring at 0. And if we look at that, here's 4 inches, 5 inches, here's 6 inches, so it's less than 6. It looks like we're right on 5.5. So I'm going to call that 5.5. So A would equal 25 multiplied by the measured distance, which is 5.5 inches. Whoops, that one needed to be in black. Ah, well, that's all right. So we end up getting A equal to 25 times 5.5 gives us a total of 137.5, and our units should be miles. Here's an example where we're going to find the scale from a movie. One of the models of a dinosaur used in the filming of a movie was only 15 inches tall, so they're telling us how big the model was. In the movie, the dinosaur appeared to have an actual height of 20 feet. What was the scale of the model? Let x represent the actual length of the dinosaur in feet. So the model was 15 inches tall, but it actually looked 20 feet tall. Okay, so the scale would be 1 inch represents how many feet? So it's the model versus the actual. So now we can go ahead and cross multiply, and we get 15x is equal to 20 divide by 15 on both sides, and we get x is equal to 1 1/3. Now, what are our units? This is feet. So sometimes that's helpful to figure out 1 1/3. Sometimes is not very helpful. 1 1/3 feet, right? Well, what is a third of a foot? If we have 1/3 of a foot, what is that equal to in inches? Okay. Well, we know that there are 12 inches in every foot. So 12 inches, if we take 1/3 times 12, that would give us 4 inches. So that tells us this is actually 1 foot 4 inches. So when we say 1 1/3 feet, if I go ahead and erase this stuff, that's equal to 1 foot 4 inches, right? There's another way of saying that. The reason I write that is the next slide we're going to be using that information. So, finding the scale factor. The scale factor for scale drawings and models is the scale written as a unitless ratio in simplest form, and the scale should be converted to the same unit of measure before dropping the unit. So when we go back to this one, remember what we had was 1 foot 4 inches. Well, that's the same as 12 inches is a foot plus 4 inches would give us 16 inches, right, for that last problem. So find the scale factor for the dinosaur model in example 2. Well, in that one we had 1 inch is 1 1/3 feet, so that's where the 16 inches comes from. We converted that from the last problem. So 1 inch is to 16 inches, so the scale factor is 1/16 or 1 to 16, which tells us that the model is 1/16 the size of the actual appearance in the movie. There's a neat little note on the side here. If your scale factor is between 0 and 1, that means the model is smaller than the actual object, but if it's bigger than 1, the model's bigger than the actual object. All right, here's a couple more problems. Find the scale factor for each scale. So remember, to do that, you have to convert these to the same units and then compare each one to the other to get your actual scale. So go ahead and pause the video and I'll give you the answer when you come back. All right, I hope you had a chance to do that. We first need to convert feet to inches, right? So 15 feet, and I hope you remember how to do this. I call this the line mole method. It's a dimensional analysis is another name for it. So we want to convert feet to inches, so we have to line up our feet diagonally so that they will cancel, okay? And we know there is 1 foot contains 12 inches, so anything in the top gets multiplied. So 15 times 12 gives us a total of 180 inches. So we could really say that this is 180 inches. So our ratio then, or our scale factor, should be 1 to 180, right? Over on the right-hand side here, we have 10 centimeters to 2.5 meters. Well, 2.5 meters, we want to convert that to centimeters, so I need meters in the bottom, centimeters in the top, and we know that there are 100 centimeters for every 1 meter. So multiply the things in the top and we get 2.5 times 100 gives us 250 centimeters, and our meters canceled there, right? So this is the same as 250 centimeters rather than 2.5 meters. So what would that give us? That would give us a ratio of 10 to 250, which is the same as 1 to 25. Okay, we always want that in reduced form. All right, lastly, earth science. Kalia is making a model of a cross-section of the earth, and he wants the core to be less than 10 inches in diameter. So here's the core right here, and he wants that measurement to be less than 10 inches. The actual earth core is about 1,500 miles. Okay, so we have 10 inches in the model corresponds to 1,500 miles in real life, right? So choose an appropriate scale and use it to determine the diameter of his model if the diameter of the Earth is 7,926. So this one we can reduce. If we divide both by 10, if we divide by 10 here, let me make this in a different color. This might show up a little better. Let me just erase that 10 right there, and we'll go in with, let's choose green. How about that? We're going to divide by 10 here, and I want to divide by 10 here. So if we go ahead and divide both of those by 10, 10 divided by 10 is 1. So it's 1 inch represents 1500 divided by 10 is 150 miles. So we can write that as 1 to 150, and that is our scale. So when it says choose an appropriate scale, that's our scale where it's inches to miles. And we're going to use that to determine the diameter of his model if the diameter of the Earth is 7,926. So what we have is 1 inch to 150 miles is equal to an unknown, we'll call it x, inches, to 7,926 miles. So now we can use our cross product. Okay, if we go ahead and multiply across, we're going to say 150 times x is equal to 7,926. So if we want to solve that for x, we need to divide both sides by 150 to get x by itself. And the 150 over 150 is the same as 1, so we just have 1x, or just x, is equal to 7,926 divided by 150, which is equal to 52.8, or approximately 53 inches. Okay, and that's what we were looking for. All right, that's it. I don't have any homework problems for you to work on to bring to class this time, so we will see you in class next time.